Welcome to the first lesson of the Moldex3D software training series. In this session, we're going to be going over how to get started in Moldex3D, and we're also going to be going over simulation iteration. Some other lessons you can look forward to include creating a project using Moldex3D Studio, importing a solid geometry into Moldex3D Studio, using CADdoctor to fix the errors coming over from your CAD system, choosing a gate location on the part, and iterating your gate location to create an optimized flow balance. The Moldex3D software suite consists of two main applications. The first of which is Moldex3D CADdoctor, which allows us to translate any part file coming from your CAD system. Moldex3D Studio is going to be the main body of what we're going to be using throughout this training series. Moldex3D Studio allows us to import the CADdoctor fixed model, mesh the model, set up the simulation by adding a material, a process, setting up computation parameters, and then finally looking at the results. So Moldex3D CADdoctor and Moldex3D Studio are what we're going to use to set up, run, and analyze our simulations. Starting out in Moldex3D CADdoctor, we can import the part using the import function. Moldex3D CADdoctor takes in step files as well as other native CAD files. The recommended import into CADdoctor and Moldex3D in general is a step file. And the reason for that is because Moldex3D is tuned to the tolerances that are exported with a step file. Your native CAD files may come in less clean and may require a little bit more fixing. After I import my model, the second button I'm going to click is the check button. Check allows me to analyze my part. It runs a 16-step checking process to analyze any errors that we may have. These errors are split into three different what we call severities. The three severities are critical, serious, and minor. Critical errors we always recommend to fix. Serious errors we very highly recommend to fix. And minor errors we can just leave alone. If you highlight any of these categories, you'll see a series of repair tools down towards the bottom of this table. And these tools can be used to manually fix that particular error. However, before we go and execute a bunch of manual repair tools, it's actually not very uncommon to have thousands of errors in here. Before we go and spend any time on manual repair, I always use the automatic repair, which is called auto heal. You can see that after we execute the auto heal function, the auto heal button turns color. You can see the arrow here turns a blue color, and we're only left with minor errors afterwards. And this is actually a very common situation. You may have a couple of serious errors left, but mostly the leftovers will be minor errors. Now, the main goal of CADdoctor is to make the modeling process more fluid. So if you're spending a long time in CADdoctor, it's really not benefiting you all that much. So I like to keep things as simple as possible when going through CADdoctor. And I'll just use import, check. The middle button here, auto stitch, allows us to repair the error called loop of free edges. Loop of free edges will occur whenever two surfaces become dissociated from one another, or if a surface is missing completely. Those will be surrounded by a loop of free edges, which could then either be filled in, or using this function here, which is called the auto stitch tool, they can be stitched together. The most common occurrence for the loop of free edges error is when two surfaces become dissociated or when they become disconnected from one another. And if that typically happens during the translation process between your CAD system and Moldex3D. Because Moldex3D is tuned to a specific set of tolerances, those tolerances may not match your CAD system, and therefore the surfaces, although they were connected in your CAD system, the surfaces may become disconnected when they come into Moldex3D. So that's what this button here is used to fix. So typically, import, check, auto stitch if necessary, auto heal, and then the last button here is export. Now the export function will allow us to export what we call an MDXSF file. The MDXSF file is specific to Moldex3D and acts like a CAD file that's been fixed by CADdoctor. And once I save the CADdoctor file, I can close out of CADdoctor. It'll ask me to save, which you can certainly do. It's not going to save the step file. It's actually going to save a remnant of the CADdoctor function or the CADdoctor application, which is really unnecessary at this point because we've really gotten what we want out of CADdoctor. So I typically don't save this file. All right, now that we've completed CADdoctor, now we can come over into Studio. Like I mentioned, Studio is kind of the all-encompassing application where we will import our model, set up all of our modeling, things like your cooling channels, runners, any inserts. We'll do our meshing, select our material process, and then run the simulation and interpret the results. So this application does everything for us. All right, so when we open up Studio, the first thing you're going to see at the top left corner are two buttons, New and Open. So I can either create a brand new project or I can open an existing project. In this case, I'm going to select New. The project that I'm creating is a series of folders that will allow me to export the information from Moldex3D. So whenever I'm selecting a material, whenever I'm creating a process, even when I'm creating a mesh, all of that information is going to be saved to this location automatically. Now the project we're creating is going to serve as a location for all of the information from Moldex3D to be exported. Things like material files, process files, even your mesh files and simulation files are all going to be saved to this folder location. So you want to make sure that this folder location lies on your computer, that meaning you don't really want this to be on a network drive. And you also want the name to be meaningful. So you can see the default here is MDX project with the date following it. We really don't want this name because if I have 20, 50 projects with the same notation, you're never going to be able to figure out which one's which. Trust me, I've been there. So I'm going to change the name to something a little bit more meaningful, and I'll press OK. Now the main procedure of Moldex3D is going to be along the top side in this ribbon, and we're always going to be going from left to right. So if you're ever confused as to what step you should be on, you should always just look towards the rightmost available icon. Moldex3D has created our first run for us, so we don't necessarily have to create a new run. But there are a couple of options that you can use. Obviously, we have new run to create a brand new run if we want to create a whole new data set. We have copy run, which is going to be our iteration tool. If you want to copy the information from one run to another, then you can make one change, run the simulation, and see what the difference is between the two runs. Import run allows us to import a run from a different project. So if I have an iterative study already set up, then I can import one of the runs from that study into this one and start making further iterations. Like I mentioned, the first run is already created for us, so we can move on to the second button. Molding type allows me to select which module I want to use for my simulation. So we have injection molding as our default. and definitely the most common. But we have a bunch of other modules that we can use as well. These modules will be tied to your license. So if you don't have the modules available in your license, you will not be able to see these under the dropdown. We're going to use injection molding for the entirety of this training series. So we can choose injection molding under that dropdown. Now under the model section, which should be the rightmost available button, remember I said this is the button you want to look towards if you're confused as to what step you're on. So right now, Moldex3D is asking me to import a geometry. And by default, this may say build model. All you have to do is click on the drop-down and choose import geometry. Now we have an auto heal option here. This allows you to automatically heal the model as it comes into Moldex3D. We typically don't recommend this currently just because it takes a long time, but you can certainly feel free to try it out. The third option here, import mesh, allows you to import a solid mesh from Moldex3D. If you already have the mesh created, you can import the mesh and then skip straight to selecting your material process and running the simulation. I'm going to use the import geometry function to import my MDXSF file. This MDXSF file is the one that we saved from CADdoctor and is a fixed representation of the original step file that we started with. Once we have the model in our interface here, you'll see that you're automatically rerouted from the Home tab, which is where we started, over to the Model tab. You'll see the first button in the Model tab is Import Geometry. The Import Geometry function allows you to bring in additional solid objects if you so desire. So if you have a runner system or a cooling system or inserts, you can bring all of that information into Moldex3D separately. You can also include them all in the same file as well. So if you have an assembly in your CAD system, you can import all of those objects at once and then assign each object accordingly. The stipulation to an assembly file is that you want all of the objects to be separated. You want all of them to be separate solid objects. For example, if I have a runner system, I want that runner system to be disconnected from the part where the two are supposed to interface. And the reason for that is the warpage of the runner, although it can be transferred into the part, we usually recommend that we separate the two just so that they can be considered as different solid bodies and therefore different solid geometries. The check geometry function allows me to make a very simple check to see what exactly is wrong with my model. Being that I've already fixed this in CADdoctor, you can see that the number of errors is pretty low. There's two errors that are really checked for here. Free edges, actually very similar to what we just saw in CADdoctor, are when two edges are disconnected, and you'll actually see instead of a bunch of blue feature lines, you'll see that the feature lines turn a red color. The second error here is tiny edge, and tiny edge, as the name might suggest, are going to be very small features, and these small features just cause the mesher to refine unnecessarily. They're not exactly the worst thing in the world. You can actually have these and successfully create a mesh. We just want to reduce them or eliminate them if at all possible, but it's not entirely necessary. Now, if you import the model into Moldex3D and you actually see errors that you don't want, then you can actually go back out to CADdoctor using this integration function. Okay, once we're done with the check geometry, you can press the green check mark. Most of the time when I go into CADdoctor and bring in my model that way, I actually can just skip over the check geometry because I'm pretty confident that my model is of good quality now. The last available button here is going to be the attribute function. An attribute is kind of a fancy way of Moldex3D asking for what we want this object to be. Now we'll see if I click the attribute function, it's asking me to select the objects to be attributed. So I'm going to left click on my part. You'll see that the current attribution is none. And that's the way it will always be when we're importing objects into Moldex3D. The default attribution is always going to be none for every object coming into Moldex, and then we just have to assign the attribute accordingly as those objects come in. So I'm going to assign this as the part. You can see a series of various different attributions under here, and they all have their own colors associated with them. So you can see that the none attribution had that dark gray, boring color. The part has this brighter beige color. A part insert is red. A cold runner is blue. A hot runner is orange. A mold insert is purple. And you can go down through all of these to see all of the different colors associated with the different attributions. But I'm going to assign this as a part and press the green check mark. The fourth button that we're going to click on is model thickness. Model thickness allows us to see a distribution of the wall stock throughout our part. Now you can see by default it kind of looks a little ugly, and the reason for that is Moldex3D is creating some sort of default mesh, and that mesh is being used to calculate the distance between one wall orthogonally from another wall. And you can see this kind of skews the scale. Most of the part in this case is in the lower end of the scale. You can see the color distribution on the part corresponds to the right side of our screen in this scale. And I can actually reduce this scale if I click and drag the top and drag it down. Let's see the color gradually change. I'm going to bring it down until we get about a dark orange to red color in some major region of my part. In this case, I have a very thick wall right in the middle of my part, and I can actually just read that thickness off. I can just kind of, go up and down. We can see this is about 3 millimeters thick. I can do the same thing for my nominal thickness. You can see that it's about 2.5 millimeters thick. And we have one more main feature right here. That's about 2 millimeters thick. A little bit more difficult because the mesh is a little bit more coarse in that region, but it's about 2 millimeters thick. So we can use that information a little bit later when we place our gate. To exit out of this model thickness, I can just simply click on Model. Over here in my what we call the project tree, I can click on this model and it will get rid of the color distribution and just show my single color part. All right, before we get on to placing a gate, let's go over some controls in Moldex3D. So the first control is going to be zoom. So your middle mouse scroll can be used as a zoom. You can also hold the control button on your keyboard and right click drag, and that will also serve as a zoom option as well. Right click drag is going to be our rotation. If I hold the shift button and right click drag, that will be a pan. And then if I left click drag, we already saw that left clicking on something selects it. But if I left click drag, this creates a selection box. We actually have two different selection boxes. The first one, if I drag from left to right across my screen, allows me to select anything that's completely contained within the box. You'll see in this case, I don't get exactly all of my part, and therefore it's not selected. But if I very clearly get all of my part, then it is selected. Going the other way from right to left across my screen allows me to select anything that the box interacts with. So you'll see that in this case, even though I don't capture my entire part in the box, I'm still able to select my part. And both of these box selects will come in handy in different scenarios. Now that we can maneuver our part a little bit better, let's go ahead and place a gate on our part. So I'm going to place a gate by simply clicking on the gate button here. It's going to ask me to add a pin gate, which I'm simply just going to click anywhere on my surface of my part. And the gate will be created orthogonal to the surface that I select. This could be a curved surface, it could be a flat surface, it could even be a fillet if you want. Not recommended, but it could be any surface on your part. This gate will be created orthogonal or normal if it's a curved surface to that selected surface. The default gate diameter is going to be customized to your part's volume, and it is going to be rounded to the closest integer. So you can see in this case it is a 4-unit gate. This value actually represents the outlet diameter of the gate, so the bottom diameter here. The top diameter is always going to be 3 times the outlet diameter. So the top diameter here is 3 times the bottom diameter. And then the length of this gate is also going to be 3 times the bottom diameter here. So we always work in a 1:3:3 ratio by default with these pin gates. 1:3:3 just meaning this value is going to exactly indicate the bottom diameter. 3 times that is going to be the top diameter, and also 3 times that is going to be the length of this gate. And that's actually all we need to run a Moldex3D simulation. Now, the more complexity you introduce into the software, the closer you can get to the real molding situation. But from a part design standpoint, if you're just trying to evaluate a good gate location on the part, or if you're trying to evaluate different aspects of part design, then you only need a gate on the part. Once we place a gate on the part, we can actually just skip straight to the meshing portion. We don't have to worry about any of the runner or mold base or cooling system or anything like that. We can actually just skip all the way to the mesh tab, where we can click generate and once again generate. Now, Moldex3D does give full control over the meshing parameters. So you can see here we're creating a surface mesh, which is this triangular layout across the surface, and then the solid mesh, which is going to be more through the thickness. So we created the surface mesh first across the shell of our part, then we created the solid mesh through the thickness based on that shell, and then we actually created the solid mesh of the runner and connected the two. So the mesher does that for us automatically, and all of these parameters are automatically specified for us. However, we do have full control over what those parameters are. And in the next session, we'll be going over how to control these parameters to create the best quality mesh possible. But for now, we're going to click on Final Check. Now, during this final check, it will ask us for the parting direction because we haven't yet set that. So we are going to make sure that Moldex3D is correctly specifying the parting direction. In this case, it is the X direction, and it automatically recognizes that based on our gate direction. So I'm going to press the green check mark. All right, it says the mesh is ready for analysis. I'll press OK. You'll see it shoots us back to the Home tab. So the next thing we're going to be inputting is our material. So you can click on the material button and it will shoot you over from the project tree over to the material tree. We're going to click where it says not specified. And you can see here that I have some materials. I have recently used materials. I have a user bank of materials. But I'm going to go down to the material wizard. I'm going to go to the bottom left corner of the screen where it says Moldex3D Bank. That's going to be our Moldex3D database. And the material database is organized by polymer type or polymer family. Some of them have subfamilies, like polyamides have a bunch of subfamilies under the polyamide name, but others, like polypropylene, don't have any subpolymers, and therefore the next structure is just your material manufacturer, and then followed by that is the polymer's grade name. I'm just going to use the first material under polypropylene A. Schulman. I'll just use this first polyflam material. To add a material to your project, you can simply double click on it, and it'll say the following material has been added to the project. And then you'll get a second prompt saying that this material has been saved to your project file. You can press OK. And you should be able to see that onto your project now. You should be able to see that your material has been added. You can close out of the material wizard. And you'll see that your material is going to be automatically populated under the material column in this material tree here. After you specify your material, we can come over to the analysis dropdown. And there's actually two types of analyses that we can run from a part design standpoint. And we are really just setting up this analysis for part design. Obviously, we don't have any complex runner system or any sort of cooling system or any inserts or anything like that. So we're just going to be analyzing the flow through the part. And the first step in analyzing your gate location is what we call flow balance. And flow balance is going to be a study of how the flow is moving through your part, and more importantly, how evenly your part is being filled out from one end to the other. The quick flow analysis allows us to do just that. We can get an analysis very quickly, where a filling analysis for this part might take somewhere around an hour. A quick flow analysis will take somewhere in the realm of 4 to 5 minutes. So we can actually do our iteration of our gate location very, very quickly using this quick flow analysis. So we're going to choose the quick flow, and then I can simply go over to the simulation dropdown and click run. And this will launch the analysis. So we're going to launch the quick flow analysis, and then followed by the quick flow analysis in this computing manager here. You'll see this run will populate right under the local host here. There it is. If you expand this, you'll actually see that there's two things being run. There's the quick flow, which is our actual analysis. You'll see that percentage will gradually increase as we start running. And then we have the project action stage, which removes a lot of the unnecessary files. So this will actually be very, very, very quick, and we should be able to analyze the results. There we go. So we say it's finished. So we can actually just go back to our project. And the first thing I'm going to do is go over to my project tree. And in my project tree, I'll go down to the bottom where it says filling. That's my filling results. If I click on that, you can actually expand that as well. This is the first result here is melt front time. And that's the color distribution that's shown here. The scale or the color distribution represents the amount of time it takes to get from the initial point, or this melt entrance at the top of our gate, to that particular location. So we can actually see that the color is pretty imbalanced. Most of the time you want to see a blue color at both of your end of fill regions. And what we're going to be studying here is the flow balance through your part, or the evenness of flow through your part. So we really want all of our end of fill regions to fill around the same time. So if we get both of our end of fill, in this case we have two, we have one on the left side here, and then one somewhere around the bottom right side here. If we can get both of those end of fill regions to fill out at similar times, then that would be considered a balanced flow. Now, to analyze this result a little bit better, I can go over to the Result tab, and I can actually play the animation of my melt front. If I press the play button, see the animation just kind of progresses. We can see at this point, you can see all of my left side of my part is already filled, and the right side of my part is still filling. So this is a very imbalanced flow pattern. We really want both sides of our part to finish filling at about the same time. Now, typically to analyze this a little bit more consistently, I will go to the VP switch point, or if you don't know the VP switch point, you can use 95%. It's usually a pretty good mark. And when I go to 95%, I can just type that in this blank here. When I go to 95%, I should see that both of my end of fill regions have not finished filling yet. So I should see that there's still some uncolored or non-filled region at my end of fill sections when I go to the 95% mark. If that's the case, then I would have a balanced flow. But in this case, you can see that my left side is completely filled out, whereas my right side is unfilled at this point. So typically the strategy is always going to be you want to move your gate closer to the unfilled region, and that will allow you to balance your fill a little bit better. And we have a very easy way to do this. Because Studio integrates the modeling procedure with the simulation setup, we can actually do this iteration very, very quickly. The first step in this is going to be to delete the gate. We're going to move our gate to a new location and rerun the analysis. So I'm going to highlight the solid mesh of my gate here. You'll see that the mesh object here has been selected. And I can simply just press the delete button on my keyboard. When I press the delete button, it'll bring up this prompt asking me if I want to continue by clearing all of my results, or if I want to keep all of my results and create a whole new run. And typically, I do want to create a whole new run because I want to preserve these results in case I need a comparison to use later on. So I'm going to click copy run. All right, so you'll see it'll bring everything over except for the gate. And actually, I'll make a small exception to that. I say with the exception of the gate. Really what I mean is with the exception of the solid mesh of the gate. If you go to the model tree, which is right next to the project tree, it's the second button in this little toolbar here. If you go to the model tree, you'll actually see that you have a cold runner object, but it's currently turned off. So if we click on the radio button for cold runner, you'll see that the gate is actually still there. All we deleted was the solid mesh representation of this gate geometry. Now, one of the cool things about gates, if they're created in Moldex3D, is that we use a line-defined method. So if you highlight or left-click on your gate, you'll actually see that there's a center line going all the way through your gate. So our gates here are actually just a curve object or a one-dimensional object with the three-dimensional properties defined by the inlet and outlet diameters of the gate as well as the length of the gate. And you can modify these if you want to by highlighting the gate, right-click, edit injection molding attribute, and you can modify parameters like the inlet and outlet diameters. So the red and green corresponding to the red and green on your gate here, and then the gate length just being the length of this line measured from the red end. I'm just going to make sure that I keep as many variables consistent as I can. I just want to be changing the gate location in this iterative study, so I don't really want to change the size of my gate and the gate location at the same time, therefore preserving the single variable approach. Now to move my gate, I need to first set up a location to move the gate to. And the most common method to do this is to create a point. So I'm going to go to the Tool tab. The Tool tab has the point function, so it's the first one at the top left corner of this Tool tab here. I want to place the gate somewhere that the flow would be a little bit more balanced. So let's try over here. Seems like it's somewhere in between these two. A little bit more than this one at least. Now, this just creates a point which is directly on the surface. That's the nice thing about the points in Moldex3D. They're always going to be created on the surface of the part. So now I can move my gate, and the way to move my gate is going to be by first highlighting it by left-clicking, right click, move selected. And the first thing it's going to ask for is the reference point. So the reference point is going to be the point that you're moving from. So obviously we're trying to move from the bottom of the gate, but you can also use this function to move other objects, such as your part, or maybe like an insert, or really any other type of object. So Moldex3D doesn't really pick up automatically where you should be moving from, therefore we need to specify that. And we're going to choose the bottom of the gate using the end snap. You can see that when I kind of move close to the end, the bottom of our gate here, the bottom of the line, you can see this little end snap pop up. I activated my snaps down at the bottom right corner of the screen. So you can see there's a series of snaps, there's an end snap, and ultimately we're also going to need the point snap as well. So we want to snap to the end of this line as our reference point. And then our destination point where we want to move to is just going to be the point that we created. The nice thing about this is because the point was directly on the surface of the part, the gate will also be attached directly to the surface of the part. So even though you see a little bit of overlap here, our mesher will be able to handle that. There won't be any overlap there when the mesher gets done with it. But the gate is directly attached to the surface. It's not like floating in the air, or it's not embedded into the part or anything like that. It is directly on the surface. So the snaps will help us to do that move much more fluidly. All right, once we moved our gate location, now we can go to the Mesh tab, Generate. And it's going to ask me to keep my attached solid mesh. So what it's asking is if I want to keep my part solid mesh. We obviously don't have the solid mesh of our gate anymore, but we do still have the solid mesh of the part, and we don't really want to get rid of that because ultimately we're going to have to regenerate it again if we were to get rid of it. So it's just kind of a waste of time if we were to get rid of our solid mesh. In this case, I will click yes to keep my attached solid mesh. And when this message comes up, you see that the surface mesh and the solid mesh for the part are already generated. Now I'm going to turn on my mesh here. I turned it off temporarily to look at the results, and you can turn on and off the mesh using this function right here. The first one allows you to see the mesh. The third one kind of turns off the mesh for you. So right now you can see that there's a remnant of the gate. So there's a refinement where the gate originally was. When I press generate, you'll actually see that this refinement will go away, and the new refinement will be created around our new gate location. All right, so now you see that we have a nice refinement around the gate and a seamless connection between these two objects. So now I'll click Final Check. We've already assigned the parting direction, so it's not going to prompt us for that. All right, it says the mesh is ready for analysis. We can press OK. And because we copied all the information from the last run, that information is brought over and it's automatically specified. So if I were to click on material, for example, you see that this material is already specified for us. And the same goes for the process and computation and also the analysis type. So that we're going to be running the same type of analysis quick flow here to be able to analyze the new gate location with respect to the old gate location. All right, so once I have the simulation set up, you can click Run, and you see it populate into the computing manager here, just the same way as the old run was populated. Once the simulation is finished, we can go back to the Project tab, go to the filling results, and turn off the mesh again. And go to my Result tab, and we can play the animation. All right, and we can see that one side does fill out a little bit faster than the other side. Again, I'm going to go to the 95% mark to see if we do have a balanced flow. It seems like this side is completely filled, or very nearly completely filled at the 95% mark. meaning that this gate location is not exactly balanced. We really want both end of fill regions to be very clearly unfilled at the 95% mark. And the further you can push this, the more balanced your gate location actually is. So we're getting a little bit closer. So let's move our gate location one more time to get a much better balance of flow. So we're just going to do that same procedure again. I'm going to highlight the solid mesh of my gate, press the delete button, copy run. Remember that the gate is hidden right now, so we go to the model tree and turn it back on. All right, I'm going to create a point, so I'll go to Tool, Point, and we'll go somewhere kind of towards the middle of this surface, like here. All right, and I'm going to highlight my gate, right-click, Move Selected. I'm going to choose the bottom of this gate, or actually the point that I created previously. So you can either use the point snap or the end snap, either works, but we're going to choose the bottom of this gate as my reference point, and the destination point will be the new point that I created. Again, there will be a seamless connection between these two, that being the gate and the part. Once I've moved my gate, again, I can go over to Generate, keep my attached solid mesh, and generate the solid mesh one more time. Now this point that we created, actually these points don't do anything as far as the simulation is concerned, so we don't actually have to worry too much about them. The points, as long as they're not attributed, or as long as we don't tell the simulation that they're supposed to do anything, then they won't do anything. They're just going to be point objects. They won't actually contribute to anything or mess up anything in the simulation. All right, so we can click Final Check. And again, we're going to be shot back to the Home tab. And all this information is still the same. And we can go ahead and click Run. You can see the analysis time for the past couple runs was about 3.5 to 4.5 minutes. Somewhere in there. All right, and once the third simulation is done running, we can go back to the project tree, open up the filling results. We'll go to the Result tab, and I'm just going to go straight to the 95% mark here. And there you go. So we actually have, you can see both of my end of fill regions in this case are not finished filling yet. And like I mentioned previously, you can push this a little bit further if you want to see how balanced your fill is. You can see 97 is pretty well balanced still. Let's even push it to 99. All right, cool. Wow, we can still push it all the way to 99%. I can probably even push it a little bit further than that still. So this gate is actually very well balanced. And this is going to lead to a lower pressure because of the lower flow length. The amount of pressure required to fill out the part is going to be lower. When we get into a packing analysis, we're going to be able to distribute the pressure a little bit better because the flow length is reduced. And we're going to be able to control the dimensional stability of our part as a result, if we're able to pack out our part evenly, or if we're able to reduce the amount of pressure requirement, then we can control the dimensional stability of our part a little bit better than if we were to have an unbalanced gate location. And that concludes our lesson. So in this lesson, we have created a project using Moldex3D Studio. We've imported a solid geometry into CADdoctor, and we learned how to use CADdoctor to fix those errors on the geometry. Coming back into Moldex3D, we selected a gate location, and then we used an iterative process to determine whether that gate location was appropriate, and learned how flow balance will impact the final results that we get out of the simulation. Thank you for joining the Moldex3D training series, and keep molding on.